Okay, here's the cool thing. We now have a couple different other types of symmetry. We have line symmetry, rotational symmetry, and now we have ones for three-dimensional figures. The first one is called plane symmetry. Now this is the same idea as like a line. If I take a plane and cut you in half perfectly, like this, if a plane can divide a figure into two congruent reflected halves, then it has plane symmetry. So this square-based prism was, bam, totally cut in half. That is called plane symmetry. We also have another type of symmetry, and that is symmetry about an axis, or axis symmetry, okay? So a three-dimensional figure has symmetry about an axis if there is a line about which the figure can be rotated by an angle greater than 0 and less than 360 degrees. So if I could literally, like, say, thread a string through it and twirl it around, will I get the same thing? Well, obviously I love right cylinders. They always have an axis of symmetry. In fact, that's your axis, so it's not so hard for us to get. Now this one says, tell whether the figure has plane symmetry, symmetry about an axis, or neither. Okay, well, looking at this one right here, this one's going to have both. Now let me explain why. That is a square-based pyramid. Can I cut with a plane, smack dab through the middle, where you can see where I'd hit right here and here, and going across, and divide it in half? I could, right? Now, how about if I put a line coming from the center, smack dab, to the center point, and I keep going down below? Can I twist it on there? If I connect that vertex of the pyramid to the center of the base, can I rotate it around? Yeah. How about the next one? Can I put a line through the middle of this and rotate on it before 360 degrees? That should be no. I can't find the line up and down. But can I find a plane? And I'm trying to think if I can draw it at all well. And the answer to that would be no. That kind of would cut it like this and down. You see what I mean? Like, you would literally have a plane that would be bisecting it. You could tell it would be cutting it in half. So this one just has plane symmetry. Now on this one right here, can I draw through the center of that base with that right cone? Can I draw an axis and can it rotate around the axis? Could I literally spin it around there? Yes, so it does have symmetry about an axis. Can I take a plane and cut it smack dab through the middle? What do you guys think? Can I get that plane that could do that? Yeah, I could cut it through. So this one has both. Now how about the next one? Now this one was argued, and I can see people saying neither, but I actually think this one has what's called plane symmetry. Where is it? It would be coming at an angle through here. I could cut it and then going kind of back. And so it would be through this back corner over here. You'd have this cut. So I can see a plane that maybe could come out and cut it like this. It's hard to see, and I'm very bad at drawing that perspective, but I do think you could cut it kind of like in the corner here, going straight back, and it'd have plane symmetry. All right, now we're going to go on to tessellations.